Bismillahirrahmanirrahim. Let us go into a new chapter, chapter 4.8. This is about integration by partial fractions. So in this chapter, we will learn on how to integrate fraction where the use substitution will not work or the trigger substitution do not work as well. So what happened is, in this case, first, before you integrate, you need to decompose your fraction or simplify your fraction into simpler fractions like this. So that is why we call it as the partial fraction decomposition. So given in your workbook, such that before you would like to decompose the fraction, you have to make sure that your fraction is a proper fraction. Proper fraction is where the degree of the numerator is less than the degree of the denominator. If the degree on the numerator is bigger, then you have to simplify first by using a long division. And then you get this. And for this R on D, then you can decompose further. So when we are to decompose our fraction, if this is a proper fraction, it really depends on the factors of our denominator. So factors of the denominator, either it is a linear factor like this, or repeated linear factor, or irreducible quadratic factor, a quadratic factor where you cannot factorize and further, or a repeated irreducible quadratic factors. So there are 4 cases that we have to look into. Like this one, x squared minus 1, you can actually factorize further. Or x squared minus x minus 1, you should factorize further. So meaning your form of the denominator has to be in a form of factors. So if you have a proper fraction, where the denominator in a factor form like this, and then you can diffract your fraction by applying these properties, right? So if it is a linear property, either the denominator is a linear, non-repeated, or repeated, case number 2, if it is a repeated linear factor. Case number 3, if it is a irreducible quadratic, so this is how we decompose it. And number 4, if it is the repeated quadratic, this is how we decompose it. Let me show you to you the example on how to apply this formula. Let us look at an example on how to decompose the fraction. Let's say we have a fraction like this. How do we break them? How do we decompose it? So you have to analyze on the denominator. Here we see that the denominator here is like case number 1, where we have a linear factor and it is unique, not repeating. So in that case, the decomposition is A over the factor itself. So here for this x minus 2, it is A, a single A, a constant number, x minus 2. And for this part, this is also case 1, so it is B over x minus 3. Later on, we will learn on how to get to this constant A and B. How to calculate the constant A and B. So there we decompose this into 2 fractions. Next, question number 2. A fraction. Again, look at the denominator. Here we have a linear factor and it is repeated. Let's say it's repeated 3 times. So this is a case of 2. Case number 2, where we have a repeated linear factor. So on how do we compose? The format is A over ax plus 1 power 1 plus ax at ax plus b power 2 and so forth until the highest power of the linear factor that Okay. For example, here we have a linear factor power 3. So how do we compose? Again, numerator is a single constant a over x plus 1 power 1. And for another one, b over x plus 2 power 2 up to c over, here it is up to power 3. So single c over x plus 2 power 3. I'm not using a1, a2, ak. I'm using ABC. Okay, it's easier to write. Alright, that would be number 2. Next, let's analyze question number 3. This here we have a linear now repeated is case 1, and here we have a form of a quadratic, irreducible quadratic, meaning we cannot factorize further. So it's a combination between number 1 and number 3. So for the number 1, so the format is a single a over the factor itself. The factor is x power 1. So that. As for the quadratic, the form for us to decompose, okay, notice that the numerator is ax plus b form. So it has an x there. Okay, it's not a single b. It's a bx plus c. I call it ABC for the constants. Bx plus c over the irreducible quadratic form of quadratic factor. Okay. Okay, next let's analyze format of on how do we decompose this fraction. Okay, so how do we break it up? Okay, so again depends on your denominator value. As we analyze, this is x minus 1 power 2, case 2. It's a repeated linear. So if it is a repeated linear, it's like this. Okay, so single a over x minus 1 power 1, and then plus, I call it b over x minus 1 power 2. If you are having it until power 3, you should continue further like this one. Okay. And then here we have x squared plus 1. We cannot factorize further. This is a quadratic form, irreducible quadratic, meaning we cannot factorize further. Okay, so if it is quadratic, the numerator will receive a variable x. So I call it cx plus d over this factor. Okay, so this fraction can be decomposed into 3 different fractions. Okay, so that is the formula. Right? Okay, last, let's look at number 5. Again, how do we decompose this fraction? So the first, again, depends on your denominator. You need to factorize. Here you can see that our denominator then can be factorized. Let's take out the x. And then we have x squared minus 1. So if you stop there, meaning you have a tendency to say a over x for the linear factor. For the quadratic, the form of the numerator bx plus c over x squared minus 1. Is it correct? This is wrong. It is wrong. Why so? Because this denominator, x squared or a squared minus b squared, can be factorized further. Okay, so you should factorize further this value. Okay, so let me write it down back. So meaning what? Okay, you have to factorize until towards the end. Here we have a form of a squared minus b squared. Okay, and from our high school work, we can easily factorize it further using this formula last time. So for this x squared minus 1, we can factorize it further such that it becomes x minus 1, x plus 1. So hence, how do we decompose it? Analyze. So this is linear. Okay, case 1. This is also linear, case 1. And this is also linear, case 1. Sorry, case 1. Right? So how do we decompose it? So it is a form of a over x plus, whenever the denominator is a linear form, the numerator received a constant value. I may call it ABC. So for the second factor, linear factor, and C for the third linear factor, which is not repeating. Right? So you have to get the format of diffraction or decomposition correct before we integrate later on. Okay, so refer to these notes if you forgot on how to decompose our fractions.